Hello, everyone. Good afternoon, and thank you for coming to this session of IoT and Cloud for industrial application. I am Indranil Chakraborty. I'm a product guy at Google Cloud Platform working on IoT. What we're going to cover today, we're going to cover a couple of industrial applications which are enabled by IoT and Google Cloud, and give you some demos by our partners and our customers on how they have leveraged the power of Google Cloud with IoT to really solve some interesting industrial problems. So let's get started. I'm sure you've all heard about the fourth industrial revolution. If you look it up on Wikipedia, industrial revolution, fourth industrial, it's said that we've been in this fourth industrial revolution for quite a few years. The first revolution started back in the 18th century when steam engine was first invented. And powered by water and steam power, it was used to mobilize and automate a lot of the production as part of Industrial Revolution 1.0. The second revolution started with mass production of assembly line using automation and in the manufacturing field. It was primarily started by Henry Ford when he started assembly line for his Ford car manufacturing. And it said that the third one started with computerization and automation of IT. So as we started installing robots and connecting those robots to the IT system, that's what started the third industrial revolution. And the fourth revolution has been going on for over 50 years, thanks to the massive advances in technologies. And we believe that with IoT and cloud, we can make further advancement in the fourth industrial revolution stage, which can help businesses derive a lot more efficiency and get a large amount of value from IoT and cloud. What we're seeing today in the industry are a couple of key trends which is driving the advancement of industrial application using IoT. First, what we're seeing is an increasing desire by the industrial players to combine data from their operational sites, so factories, utility grids, and other sites, and combine it with their IT systems, so that they can really get the value from both this data and derive a lot more efficiency and improve their overall production as well. So that has been one of the key drivers that's what we're finding in the industry. The second is it has really become much easier to extract data from factory and other industrial sites as well. If you think about it, when we say IoT in industrial scenario, a lot of the manufacturers have already had installed sensors in their machines. So these machineries already had instrumented with sensors. And they're collecting a large amount of data. But only a very small percentage of this data is actually getting utilized for many of these applications. And so as the prices of sensors keeps dropping thanks to the mobile phone revolution, we're seeing a large number of these industries are either using these existing machines which are instrumented with sensors, or are retrofitting machines, legacy machine, with sensors which can then be connected to cloud for deriving a lot of value. And finally, over the last couple of years, cloud technology providers such as Google Cloud Platform has done a lot of improvement to ingest massive scale of data and then store it in a very cost-effective way. In addition, the Google Cloud Platform and others have also been providing machine learning capabilities, so you can really extract very meaningful insights from this data. And so as we think about industrial application, there are a couple of use cases we need to think about what are the key use cases we want to address as we start building IoT applications for the industrial use cases. And so, you may want to improve your overall efficiency of your product line. There are players and customers who really suffer a lot if there is any downtime in their machineries. And so they want to use data and apply analysis on those data to predict a failure so that they can avoid any such downtime. Real-time tracking of inventory is also a key use case because you can use that to not just avoid inventory stockout, but you can also use it to predict demand so you can make sure that there's enough inventory as the customer demand increases. And of course, product quality is one of the key areas where a lot of our customers and partners are very interested in as well. Asset tracking and supply chain, among other ones as well. In Google, as we think about these use cases, and as a developer or as an industrial partner, as you think about building applications, IoT applications for industries, there are really two key areas which you need to solve in order to address any of these use cases. One is you have to be able to ingest massive amount of data across different sites, and then be able to process it at scale, and then tease out key insights so you can really apply those learnings and get some business value. And in Google Cloud, we have a number of these services which allows us to do that. And if you think about it, Google has been working on big data for over a decade, right? So we have been working on ingesting data, processing data at scale over a decade now. And we think we can apply the same services for industrial applications as well when it comes to the context of IoT. So I'm going to spend some time on a couple of these product offerings which we have for ingesting and processing, analyzing data at scale. The first thing you want to do is, if you think about IoT and data you get from sensors, while individual sensors, which are either instrumented in the machines, may be generating a couple of bytes of data per second or per few seconds, but when you look at it from a cumulative perspective, it generates a massive volume of data. And so you want a system which can ingest data at scale, massive amount of data at scale, and PubSub is a great product for this. Essentially, what you do here is you have IoT devices or sensors which can publish data either directly or via a gateway to a particular topic, and then PubSub and then you can have other services to consume data from that topic for further processing. There are a couple of key benefits of PubSub. One is its durable message persistence. Now, what does it mean? The sensor data, since it's constrained, you need to be able to send the data without much challenge, and it shouldn't have to try to resend data every time. So PubSub makes sure that once the data is published, it is durably stored until the consumption party sends an ACK back. The second advantage of PubSub is it's a global service. While your sensors and industrial sites might be distributed globally, you want a central location. Your consumption must be having in a central location. And so you don't have to, since PubSub is a global service, you don't have to worry about what is happening with what happens if my New York service goes down, or what happens if my San Jose service goes down. It's a global service, and we scale automatically. In fact, PubSub can scale from handling few thousands of data per second to millions of messages per second within just a couple of minutes, without user or the developer needing to provision any additional services. And finally, it also allows you to separate your upstream device deployment from your downstream application. So you can continue to build and iterate on your application, which is consuming the data from all these different IoT devices, without needing to change or modify your upstream deployment. In fact, you can use it to route the data to some of the cloud services, such as Dataflow, Cloud Function, or even your own existing ETL's pipeline as well. Once you've ingested the data at scale, the next you want to do is really process it. And for industrial IoT applications, often the real-time analysis and real-time insights becomes really critical. And so Dataflow is a great product which allows you to constantly receive data from PubSub, stream of data from PubSub, and then analyze it continuously analyze it. So you can run You can compute average over a stream of data within a certain window. You can even use it to convert data format. So you have devices across different industrial sites, and most of the time, devices have different data formats. And before you want to store it, if you want to convert it into a standard format, Dataflow is a great product for that as well. And in addition, Dataflow can also be used to get data from other services, such as your weather data or traffic data as well. And Biqquery allows you to store massive volume of data and run near real-time analysis on those data as well. In fact, you can run a query on Biqquery which has got 100 billion rows of data and get a result within a couple of seconds. It's that fast. And finally, once you have stored all this data and have run some basic analysis, you can then apply cloud machine learning to get some more interesting and more sophisticated insights out of it as well. So the industrial revolution is already upon us, and what we've built so far is a cloud services which can be applied to build really interesting applications. Now what I'm going to do is I'm going to invite our friends and partners to showcase to you some of the example demos they've built using our cloud platform, which is planning to solve many of the industrial applications. First, I want to invite Willem, who is CEO of Odin Technologies, and they've built a really interesting application for manufacturing. Willem.
Thank you. My name is Willem, and as Indranil said, I'm CEO and co-founder of Odin Technologies. How many here had heard the term Industry 4.0 before? Oh, quite a lot still. Thanks for that introduction. There was a great survey done by German manufacturers, 1,000 of them, to gauge the level of know-how and excitement about this new trend and buzzword. And about 50% of them said that the Industry 4.0 was actively being planned and discussed in their plants. Around 80% said it was going to have a long and lasting dramatic impact on the industry as a whole. About the same 80% said it was going to give them a competitive edge. But only 27% said that they felt like they knew what it was. So half the people are talking about it. Everyone thinks it's going to be awesome, especially for themselves, but very few actually feel like they know what it is. In our opinion, Industry 4.0 and Industrial Internet of Things, all it is, it's a new way for, well, it's about leveraging data and technology to take better decisions faster. Because the problems that are facing manufacturers, the industrial challenges, or their business outcomes and goals haven't changed. Sorry, I haven't clicked. Haven't changed in the past 10, 20, or 100 years. They still want to make more as efficiently as possible. Use as little energy as possible, use as little material or time as possible. If you look at US manufacturing as a whole, it's easy to think of only the top brand name manufacturers when you think of manufacturing, the Teslas of the world, or the Rolls-Royce of the world. But US factories had an output in 2015 of $6.2 trillion. That's 36% of GDP. Most of those companies are not Rolls-Royce or Tesla. Most of them are material processing companies, making components for these larger manufacturers. A normal car is built up of 30,000 components, all coming from a complex network of suppliers. And take the US plastics industry as an example, where we've gotten our start and we have our biggest focus right now. 16,000 factories in the US, where most of the data that they collect and analyze and use for continuous improvement is done with pen and paper, clipboards and timers to try to understand and optimize their production. So if they have a problem with a rejection, a quality problem, or they're trying to optimize the material consumption of the settings, or trying to understand a machine failure, when that problem happens, they send engineers out there to monitor it with pen and paper to take the data in and then formulate hypotheses and try to do the root cause analysis. So problem solving can take weeks to months. Now, I'm not saying that there is no technology in manufacturing, but the technology that's out there has been only accessible to those 1% of manufacturers. Hardware's always been built on programmable logic controllers, stemming from the 70s. Not a lot of people are studying ladder logic anymore. Software, the design of software usually looks like it's from the 90s at best, sometimes from 80s, more resembling MS-DOS. Software is usually hosted locally, and it's always extremely expensive and difficult to implement. It can take months to years. But it doesn't have to be that way anymore. Through ubiquity of networks, drastic decrease in cost of electronics and cloud computing, coupled with the tremendous tools and power that's available now, superior industrial technology, or superior technology in general, is now available to manufacturers, large and small, in all different verticals. The technology that has helped us in our consumer lives to click more links and buy more stuff on Amazon can now be used to eliminate waste in manufacturing. And that's our core mission. We founded Odin to empower manufacturers with data and tools so that they can eliminate their waste in their production, decrease or eliminate scrap rates, decrease or eliminate machine failures and unplanned downtime, optimize settings and material consumption so they can make more with less. And we do this by delivering a device built on Raspberry Pi that we can communicate with most industrial machinery or external sensors, capture data in real time from the machines, send wirelessly to our cloud-based analytics platform, and there our customers, or process engineers, quality engineers, industrial engineers, manufacturing engineers, or executives at these facilities are using the platform daily to solve quality problems and machine failures. A process that normally took weeks or months now takes minutes. And we do this completely on Google Cloud. So the millions and millions of data points that we take in per production line per day is ingested with PubSub. Our real-time stream processing framework lives in Container Engine. We're in the process of moving that to Dataflow right now. As an example of the stuff that we can do there, we can take laser measurements of the output coming from the machine, calculate in real time the volume of that product. With the speed of production, we know the flow rate of material. We also know what density that plastic has, so we can know how much pounds of material they're using per feet, per hour, per RPM, per percent horsepower, in real time and historically. Their set points and their actuals means that you know how much waste there is and where it's coming from. Oh, yeah. Let's switch laptops. So customers can get a real-time stream of everything that's happening out on the production line. Purple one is the target of where they should be. The green one is the output coming from the machines. You have the yellow is the melt pressure, so how the material is actually behaving as it's leaving the machine. This can be put as an HMI, as a human-machine interface, down on the production line for people. You can add whatever metrics you want, original or calculated. You can have a high-level overview over your throughput utilization across lines, across factories, for execs to understand more how they're running. You have complete traceability, so you can search through your production based on product, based on time, based on events that have happened. So if an engineer is trying to solve a problem, what they do is they search for whatever product they were running, whatever time frame it happened, or for the event itself. They can then open it up. I was slow when I was recording this. They can open it up here, and problem solving in manufacturing is like peeling the layers of an onion. You don't really know where to start, but here they'd start with the most important process variable for them, the output diameter. This is a cable extrusion example. They looked at the melt pressure of the plastic. They look at the melt temperature of the plastic. They look at the nominal to see where they actually were. You can zoom down to a second level granularity on the data. So here they've identified a certain problem where the fluctuation of the cable, the diameter, was out of tolerance, which causes return loss in the cable, which means that the customer can't use it. So you can then, identify exactly where that happened, so you can cut it out and sell the rest. You can also understand why it happened. So in this case, it looked like it was the motor load that all of a sudden changed the pressure, that changed the amount of plastic that ended up going out on that cable. You can also, once you've identified something, you can select certain parts of it, either for statistical processing or to label it. Labeling allows you to find it again, share and collaborate, but also to train up machine learning models so that both different states of your production can be classified automatically and different failures can be predicted in the future. I think that's it. I think we can switch over to the presentation again. So in the same way that we build tools and capabilities that allows our customers to run their factories more efficiently and build better products, Google Cloud Platform does that for us. We can move a lot faster and build better products for our customers by leveraging the tools that Google Cloud Platform provides. We also know that we can scale comfortably throughout this year, going for tens of thousands of machines and thousands of factories without having to worry about scaling up Bigtable or our data pipeline itself. And that's it from me. Thank you very much.
Thank you, Willem. So you saw how Willem and his company are using Google Cloud to really solve a critical problem for manufacturing, where they can now have a view of exactly how their machines are operating, and they can take more predictive action, proactive action, rather than waiting for days and using clipboards to figure out where things are going wrong. Another area where we see a lot of opportunity and in terms of where cloud and IoT can really help is in asset tracking. And we've been working very closely with our friends and partners at Intel to build some interesting applications and demos for you guys to share with. So let me invite Giby Raphael from Intel, who's going to talk about asset tracking. Giby. Thanks.
Good afternoon. So I run the logistics segment at Intel. Let me begin the presentation with 3 stories. The slide doesn't move. Yeah, let's go with stories. So the first story comes from our own backyard, from Intel. Intel is the world's #4 largest supply chain. We ship more than 1 billion products a year across hundreds of countries and thousands of places. About 30 to 40% of that is fabrication equipment. And we have problems. We ship this box-sized equipment, and this is 2016. We still use ink sensors, analog ink sensors, to sense tilt. These boxes cannot be tilted. These boxes have a vibration threshold, and it loses calibration if it exceeds the threshold. So we stick on a tilt sensor with 2 compartments. If the ink leaks from one compartment to the other, we know it tilted. But we don't know how many times it tilted, where it tilted, how it tilted, so that we can use that information next time. Even worse, since a person is involved in looking at and reporting it, oftentimes it doesn't get reported. We have had stories where we ship these boxes across international borders, across countries, and we have to bring it back for calibration. Obviously, Intel can afford shipping costs to bring the box back, but what we cannot afford is if the fab gets shut down for a day or 2 because of this, that's millions or tens of millions of dollars in loss for us. The second story comes from a flower retailer in New Hampshire. So last year, during Valentine's Day, he got a truckload of flowers from Florida. The flowers got spoiled around Texas, Midway. Nobody knew about it. The night before Valentine's Day, he got a truckload of rotten flowers. Right? $50,000 written off. It's probably no big deal. It's a big retailer. But what he couldn't afford is the loss of reputation. Right? The single most important day where you're supposed to sell flowers, he ran out of flowers. Those customers are not coming back. The third story hits a little closer to the heart. 2014 Ebola epidemic in West Africa. A plane load of vaccines got spoiled. Nobody noticed it. And by the time they realized it, it was too late. There was no time for plan B or a contingency plan. People died. So these are not isolated incidents, but it happens every day across the world. 70% of all companies in the world experienced a supply chain disruption over the last 12 months, and 20% of them went out of business because of that. Last year, approximately 76 billion packages were shipped across the world, and 30%, right, that's more than 20 billion packages, were damaged, delayed, or lost. $60 billion of cargo value was stolen last year. On average, this is mind-blowing. Every single day, on average, in US, 2 cargo thefts happen, on average. And the value of the theft is in excess of $200,000. I grew up in India. 65% of fruits and vegetables in India doesn't reach the fork from the farm, right? At that magnitude, we're looking at making a dent on world hunger. We believe that using real-time technology, real-time tracking of the location, the condition, and security at the package level can solve this, can bring it down. But why has it been done before? Why is nobody doing it? 3 reasons. Cost, 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 right? Once I put a decent compute, the memory, and a modem in a box, it'll now cost me $100 to $500. I cannot put them on every package, right? It's too expensive. But unfortunately, all these problems happen at the package level. Theft happens at the package level. We send armed guards in certain countries when we ship our server processors, right? People run away with the package. Each package is $100,000. Tampering happens at the package level. Tilt, vibration has to be sensed at the package level. That's just the CapEx cost. Then there's the OpEx cost. Shipping is one way, point A to point B, but these things have to be brought back, right? So this is, you need to close the loop there. And especially if it's across international borders, 40% of the time it's not coming back. Even when it comes back, you have breakage, delay, you have to pay for the shipping, it's a mess. That's when we looked into IoT and cloud, right? How can we solve it? So we invented a platform with the vision of bring down the unit cost of tracking to sub $10 to begin with. And obviously, as everything else, it scales, the price drops with scale. Let me highlight three features of this platform before, after that, Josh will come and demonstrate our prototype here. Number one, we looked at, hey, at the package level, what do you need to sense this? So we need a basic compute at the package level, an MCU level compute, and sensors. Then we looked at, hey, in order to take the data from the package to the cloud, what do you need? I cannot put a long-range radio. I cannot put a modem in there. It's too expensive. Can we put a short-range radio in there, right? But by definition, problem is it's short-range. So we invented the world's, probably one of the smallest power mesh network out there with multi-hop that will now solve the range problem to a large extent. It also solves the density problem where I can now have 1,000 sensors talking to one modem to upload the data. And finally, a page from cell phone analogy. We have a software IP where now the sensors can move from one modem to the other, which basically means I can have fixed modems, fixed gateways in trucks, in planes, in trains, in warehouses, in airports. And once I build this infrastructure, I'm only paying for the sensor at the package level. Josh will now demonstrate a prototype we have here.
So if we go to the slide here. So just to provide you with a little bit of context around what Giby was talking about and what we'll be demoing today. This slide here shows you, on the left-hand side, a pallet of goods. So we have, in this demo, we'll be showing you, on the far side over there, you can see our mobile gateway. These are prototypes, so these are meant to be big and bulky because they're prototypes. And I'll show you a little bit of what the production form factor will look like here in a minute. On the left-hand side, you can see a pallet of goods. So we have a mobile gateway that would be placed on a pallet. And then we have a whole bunch of boxes on that pallet. Each one of those boxes you would be instrumenting with a sensor. Giby talked a little bit about this concept of having a fixed gateway and a mobile gateway. What we're going to be demonstrating today is the mobile gateway. So there in the center of the picture, what we're going to show live on stage today is these prototype sensors, which have a 3-axis accelerometer in them, and they also have a temperature sensor. So with that 3-axis accelerometer, we can tell things like tilt, and we can tell things like shock or vibration. And depending on the algorithm, you could determine the difference between a fall or a collision. So in this architecture, we're using GCP. So we are publishing the data to the cloud using PubSub. And then once you see the UI here in a minute, you'll see we're storing aggregate data in Cloud SQL. We're persisting it there to look at aggregate historical data. And then I'll show you a real-time example as well, where we're going to use Firebase to broadcast the data out to the UI, where we're consuming it in real time. So if you want to go ahead and switch on over to the UI. So what we're seeing here, this is the dashboard page. So what this is meant to represent is a high-level overview of the data. So this is looking at a map of a shipment, a real shipment that we took from Chandler, Arizona, out into the middle of the desert. On the left-hand side there, you can see a history of a temperature exception that occurred. So when we got out into the middle of the desert, we set a threshold on these sensors that said, if it drops below a certain temperature, let us know. And you can see in this example, it dropped down to 21 degrees Celsius, but you get the geolocation where that occurred, and you get the time that it happened at as well. Down below, you can see a historical trend of temperature data. So this is real temperature data coming off this real array of sensors over the last few days as we've been demoing out in the demo booths. So that's showing you an aggregate view of all the temperature for all the sensors on average. Below that, we have some Art of the Capable slides or charts. So this is a 4-up chart that shows you kind of min and max temperature over the life of a shipment for each one of the sensors. So you can see what that looks like. On the right is a tilt occurrence, so you can understand which axes was the package tilted on, so that you could do something with that information, like issue a reorder if it was tilted and it shouldn't have been. Down below, you can see exceptions, kind of a view of all exceptions that have happened with this shipment, as well as that same kind of data, but as a stacked bar chart for each individual sensor. So you can see if you have a particular package that's been getting a lot of temperature exceptions or tilt exceptions. You can see most of those exceptions are temperature exceptions because we've been running this for real out in the demo kit, or out in the demo booth, and we've been putting these sensors in the cooler a whole bunch, showing it off to people. So now we're gonna jump into the real-time portion of the demo. So this is where we're using, on the previous page we were using Cloud SQL to render all that data, or to persist all that data and consume it on the UI. Here we're using Firebase to actually put the data out on the UI. So you can see that these cards are helping you visualize what's going on with your packages. So each one of these cards represents a package, right? It's a sensor, but the sensor represents a package. And you can see one of them is red. It's red because we have a sensor that we put in the beginning of this demo into the cooler, and it dropped down below the preset threshold that we had set for that package that we cared about. So when that happens, you can see it here on the screen, or more likely what you would do in a real world scenario is you'd use an API to push that data and go take some sort of action on that. You can also see any tilt occurrences that occur. So you can see a few of those are having tilt occurrences right now. So we have this concept of a microframe and a macroframe in this architecture. So the microframe is, for demo purposes, set up at 20 seconds. So what that means is every 20 seconds, if there's any sort of exception that occurs, something that's outside of the control limits that you've set, we're going to broadcast that data up to the cloud, in this case using PubSub. And that allows you to do something with it. A macro frame, for demo purposes, is set at 1 minute. So what that means is if everything is okay, if everything is within tolerance, once a minute we're going to send that data up to the cloud on a 1 minute basis. So if you go ahead and click on the Give Me the Deets button for the sensor that's below temperature threshold, you can see here where we've put it in the cooler, taken it out of the cooler, put it in the cooler, and taken it out. This is the same kind of data that I showed you on the dashboard, but this is for an individual sensor. So now we're looking at an individual sensor's data. So you can see all the exceptions that have occurred with that sensor, and you can see the majority of those are temperature exceptions. And then below that, you can see a historical trend of what's gone on with this sensor. So that's temperature trend over time. And then below that, you can see that we have all the historical data stored, which is being served up on the page, and the data is being stored again in Cloud SQL. If there's any exception that occurs to these while they're live here on stage, you would see that here as well. They would pop up to the top of the chart, and you would see those here in real time as they happen on that every 20-second interval. So that's basically the demo of the Intel Connected Logistics platform. And I think I'm going to hand it back to you, Giby, so you can kind of wrap us up.
Thank you, Josh. Do we have to switch computers? OK, good. So where we are going with this is what I call the visibility cube. Real-time mitigation trend analytics, so you can learn from your mistakes, and the holy grail, which is predictive analytics, right? If a bad thing happens, it's good learning, but if you can prevent it from happening, that's a whole different level. We want to create the glass pipeline, as they call, for end-to-end visibility. And as the picture shows it here, a world of autonomous freight. In our view, that's what this is heading, where the supply is automatically quenched by the demands, filled in by the demands. And we believe that supply chain is an $8 trillion market, and there's at least $2 trillion of efficiency to be gained in supply chain today, and it's ramping up to a $10 trillion market in 2020. Thank you.
Thank you, Giby and Josh, for this fantastic demo. So as you can see, using sensor technology and cloud, you can not only track real-time the tills and the other changes which are happening in your asset, but you can also plot a complete historical view of it, and that can be used for a lot of predictive analysis as well moving forward. Now, so you've seen manufacturing, how that can be transformed. You've seen how asset tracking and logistics can be transformed. At home, we've been getting used to Nest thermostat and how you can have smart meters which can really automatically adjust based on your need and based on your power consumption so that you can optimize it over time. But there's a huge industry out there around utilities which is still struggling and in order to sort of benefit from the cloud technology and overall data analysis as well. We have a partner with us, EnergyWorks, who's been working very closely and working hard with us to help improve the utilities and get more insights from their data and help their overall efficiency as well. So let me invite Edwin Poot, CEO of EnergyWorks, to show you some demo on utilities. Edwin.
Thanks, Indranil. Great to be here and great to talk to you about EnergyWorks. I was wondering here, are there any people here in the audience from the energy industry? No? Oh, a few, okay. Well, everyone in the daily life is affected by what I'm going to explain to you. So the energy industry is in a transition. And instead of looking only at the grid and the sensors and the smart meters that we are ingesting data from, there are other kind of data sources that are coming into that same infrastructure that the utilities have currently, mostly on-prem. If you look at this slide, for example, you see spatial data, open data, weather data. Most of the time, only smart meter data is being used. For example, correlation with weather would be very simple. Some of them are doing it, but most of them are not. It's not about looking backward. It's also about looking forward and what you can do with this data in the here and now. So it's more about streaming. So most of the utility customers we're working with are currently in the process of going from batched to streaming data. So you're probably familiar with the smart meter. Indranil already mentioned it. The smart meter itself, frequencies are around like 50-minute intervals or 5-minute intervals. So this is not that bad to ingest, but we are working with customers, for example, on the smart grid sensors, where we work with microsynchrophasor sensors. They produce up to 512 values per cycle, which could be like maybe 30 cycles per second, ingesting of data all the time. So we want to discover information from that data while it's streaming in. So the conventional utility systems are not able to keep up with this data diversity. So it's not only about the sensor data itself, but how can you add context and enrich the data itself that's coming from the sensor by using data, for example, from the asset management system, data from other sensors nearby, or maybe social data, even weather data, sociological, demographical information, anything that's available that can enrich the context of your device or of your time series of that data set would increase the value. So utilities are facing a change. Maybe I mentioned it before, the energy transformation. It means they have to change from a commodity-driven approach, business model, to a more data-driven business model. So it means they have to research other possibilities on how to work with data. Imagine like top of mind, energy will be free. So you don't pay for your kilowatt hours anymore. How are they going to build their business model? So that's the key. That's what they're struggling with currently. So that's why EnergyWorks made it our mission to enable this energy evolution by uncovering and monetizing this hidden value in the data. And we have a process in place to handle this. So it starts with the ingestion of data, because we want to control the entire process from ingestion all the way up to monetization. Because data quality is most of the time very poor. It's so poor that you cannot work with certain business cases or use cases, and the product cannot become viable because of that. So ingestion of data from sensors, from actuators, from smart meters, either push towards our platform, or we read it in by connecting to those devices, either via our IoT gateways or head-end systems, or directly connecting to those devices, like, for example, solar inverters, or EV charging points, or smart meters directly. And then we crunch the data. We add value to the data. We try to correlate the data. We try to discover patterns in this data, so we can learn from this data. So one of the things we're going to show you today is the interactive mode of our platform, where you can actually explore the data, work with the data, see what's happening by zooming in, interactively looking at the data. While having said this, we can also run the same thing at cloud scale. So once you have found that perfect model, that perfect algorithm, maybe your data scientist is working on this, and then with one click of a button, you can run this at cloud scale across millions of devices while data is being streaming in. And finally, of course, you can monetize this perfect application or algorithm that you want to launch in this market. Before I go into that, I first want to explain to you the energy value chain. So, starting from generation all the way up to supply, EnergyWorks facilitates this entire process by enabling our data intelligence across the entire value chain. So, for example, on the generation side, we work with providers that provide renewable energy. So they have to manage that energy. They want to see what's been generated, what's happening with the generation, etc. They want to predict it. On the transmission side, the distribution side, grid imbalances, congestion management, etc. There's a lot of data coming there as well. Some of the data is like not real time, like batch oriented, or maybe even a week old. But some of the data can be streamed in live. Then we're going to talk about energy deal analytics use case today, which we're going to demonstrate. So let me skip that part. And then last but not least, the supply side, which involves like consumer engagement, social energy kind of applications, and time of use rates. EnergyWorks is built on top of Google Cloud Platform. EnergyWorks believes in a serverless architecture, which means we don't want to work with servers directly ourselves. And of course, in the end, our software runs on servers somewhere in the cloud, but we don't want to be bothered with it. So that's why we don't use, for example, compute engine or container engine. Everything is running on platform as a service. So on the collect side, we use App Engine for our REST-based API, if customers want to integrate directly with our platform. And sometimes we also use Cloud PubSub, especially for utilities that want to have like a streaming, a possibility for streaming in data. So the second step, the processing side, we use Dataflow very intensively. We use it for ingestion of data. We use it for cleansing of the data, manipulating the data, checking or applying validation rules, etc. We use Dataproc as well for certain small analytics. Then on the store side, you see a lot of different cloud storage platforms that we use. You might wonder, why is this? So we believe that data with certain characteristics should be stored in a data store that is best suitable for those kind of data sets. For example, relational data, you shouldn't store like in Bigtable. You could do it in data store maybe, if you split it up in key values, but queryability of data is very important. So we store time series data in Bigtable. We store relational information in Cloud SQL, which we're now upgrading to Cloud Spanner. We use cloud storage as an intermediate staging store as well. And for example, if you're streaming in data and you want to apply logic on data itself, it's very important to realize which data store you're going to use. Not to mention the cost, of course. If you use certain products, for example, with data store, you pay per operation. With Bigtable, you pay for the nodes you use and the amount of concurrent connections. Then last but not least, the analyze side. We use App Engine again to expose this information to the outside world, so customers can authenticate against our API, which we tightly integrate normally with their existing platforms. We use CloudML for analyzing the data itself. We have some sophisticated TensorFlow models, for example, for anomaly detection. And we use Biqquery for certain reporting capabilities. So my colleague Eric is going to step on stage in a minute. He's going to explain some of the use cases we've been doing. And one of the use cases we've been doing is the risk management case. For a Fortune 500 energy retailer in the US, based in Texas, we automated their business critical process for pricing and forecasts. So they could get better insights in risk and risk reduction. So the risks that they sometimes run into is like they could be 100 million or 200 million. So they service like 100,000 or maybe a million customers, C&I, commercial, industrial, but also residential customers, and they are buying energy from the market. Short-term, mid-term, long-term, could be hundreds of millions of dollars. So we provided them better insights with pluggable validation, estimation, and editing capabilities. That's a specific energy industry term, by the way. But also with benchmarking and scoring capabilities. So during the entire process, we're able to see what the quality is of the data itself with some scoring indexes and scoring figures. So we could provide an accurate energy demand and load forecast. We were able to reduce their process from 8 hours, or sometimes even longer, to minutes or even seconds, from 6 solutions to 1 centralized view. So with only, for example, the load analyst team that they're working with there with 40 people, doing 10 customers a month, they could suddenly do more than 1,000 a month. So from inaccurate data to measurable data quality with a bottom line impact of $50 million plus. And by the way, the screenshot you see here is the business application. And my colleague Eric van Wijk, he's going to go show the demo in a minute. He's going to show the interactive view of this business application. So I want to introduce my colleague Eric van Wijk. He's going to do the demo.
Okay, thank you, Edwin. Hi, my name is Eric, and I'm going to show you a little demonstration about EnergyWorks Deal Analytics. But before I do that, I will first give you a little bit of context about EnergyWorks Deal Analytics. EnergyWorks Deal Analytics is used in the pre-deal process of a utility. And the pre-deal process is inspecting data from industrial smart meters with a resolution varying from 5 minutes till an hour. And while inspecting that data, they need to improve often the data quality. So they need to fire validation rules on these data sets coming from the smart meters, and they have to normalize it. And then if the validation detects that certain KPIs are not met, then we can automatically estimate it and fill gaps and stuff like that. And in the end, we aggregate all the data, and then the final result will be generating a forecast based on the improved quality data. And a better forecast means less risk for the utility and a better propositions to their customer. And like Edwin explained, the commercial offering, we brought it back from several days to minutes. And the nice thing, we completely automated this deal analytics process for the utility pre-deal process. How this looks like on a high level view in our Google Cloud backend system is it's completely serverless. It's all based on PubSub and Dataflow and the different storage types like Edwin explained before. So data from smart meter is published on topics, and Dataflow processors started validating all that data, estimate where it is required, and generating forecast. And one of the validation rules that we use is making use of a TensorFlow model. We're experimenting with that. We created a TensorFlow model to detect specific outliers in the consumption data coming from the smart meters. And in the demo that I'm going to demonstrate right now, I'm going to zoom in a little bit on how we flag the data. So raw data is coming in, it's poor quality, and I'm going to show you how we flag the data and how a data analyst in this pre-deal process can drill down and inspect that data and play around with it. So please switch to the demo screen. This one is working. Okay. I have to start running it again. The nice thing, what we did for the utilities, we have a serverless architecture, and the good thing is that all our utility customers are all running on the same code base. And that's also a really big advantage for us, that we can make use of GCP platform tools. We don't have to worry about scale at all. We can connect 1,000 utilities if we want, and just the backend system will scale as it goes. And in the meantime, it's now rendering the data ingestion. We're now having a look at, we're zooming in on the data of a particular smart meter. And what we have here is the raw data as it is coming in, as it is published on the topic. And if I zoom in on this data, you see that it contains all kinds of gaps, and it's really looking like bad quality. There's a lot of gaps, and this data, in this interactive mode, we can run all the validation rules like we run on cloud scale, but we can run it in this interactive tool that we created for the data analysts of the utilities. And we can enable particular outlier detections that we created this our TensorFlow model for. And this is live demo a problem. Like I'm running it again. So what it's doing now, it's reading the data again, it's providing all the validation rules, and it's estimating where the KPIs are not met, and then it will visualize the results, and we see it here. Okay. The TensorFlow model detected outliers in this data flow. And I can drill down on this particular, as an analyst, I can zoom in on this data, and this is an outlier. Like, this is caused probably by an industrial engine that broke down for several days and didn't consume the data that it should consume in normal operation. And to be able to create a forecast based on this smart meter data, we want to get rid of all the outliers, because that's going to influence the forecast, and then we cannot create the right commercial offer for the utility customer. So what an analyst can do now, it's detected this outlier, and we can now estimate the value as if this engine never broke down. So we are going to use a like day estimation. So it's searching for similar days with, for the consumption in this particular meter. And now the orange line is reflecting the situation like this engine never broke down. So this dip is reduced, and the gaps are filled. We have a linear estimation to fill out missing data, to fill out the gaps in the data. And in the end, we can show a merge of all the estimations that we have done for this particular data set. And if I zoom it out, then and only show the merge line, then this will be the end result, the improved quality of the raw data that was fed in. And this can be used to generate a forecast that can be used for commercial products. The analyst can also, on the right side, view the KPIs that belongs to this estimation and validation rules. So it can tweak around with different validation rules, try different estimation methods to make sure that the KPIs are met to be able to generate the right forecast. Basically, this is what I wanted to show you guys. If you want more information, just speak out. You recognize us on our Energy Works t-shirts. Ask us questions if you run into us. I'll give the word back to Indranil.
Thank you, Eric, and thank you, Edwin. This was fresh out of the oven. So what you saw today was how we use IoT and cloud to monitor real-time data in the factories and to use that to solve a lot of the problems which can be done in a proactive way. You also saw how IoT and sensors and our cloud platform can be used for logistics and asset tracking as well. And as Giby mentioned, it has the opportunity to save around $2 trillion or so. And finally, you saw how the smart meters, using smart meter data and utilities data, you can really help the utilities to get much more efficient over time. So we think we are just getting started. We think that industrial IoT is at the point of inflection. And with IoT and cloud, we can really transform multiple industries over the next couple of years. So we're very excited, and we want to thank you to join us at this session. Thanks a lot.